I'm Daze Thomas, Assistant Professor, Department of Artificial Intelligence and Data Science from SNS College of Engineering. Last classes, we discussed about deadlocks and deadlocks handling methods. So in today's class, we'll discuss about avoidance algorithms. So if a system is having a single instance of a resource type, then we use resource allocation graph for deadlock avoidance. And if a resource is having multiple instances, then we use Banker's algorithm. So we'll discuss in detail resource allocation graph and Banker's algorithm. Resource allocation graph scheme, we have an additional edge called claim edge, which is from a process to a resource, directed edge from a process to a resource, indicated that process pi may request a resource rj represented by a dashed line or a dotted line. Claim edge converts to request edge when a process requests a resource. Request edge converted to a assignment edge when the resource is allocated to the process. When a resource is released by a process, assignment edge converts to a claim edge. Resources must be claimed a priori in the system. So this is all about resource allocation graph scheme. Here is an example for resource allocation graph where you have two processes P1 and P2, two resources R1 and R2. Both resources are having single instance. You can see a dotted line from process P1 to R2, that is a claim edge. Also process P2 from process P2 to resource R2, that is also a claim edge. These may be converted into a request edge and later it can be converted into an assignment edge. This is an example for unsafe state in resource allocation graph. Here the system is an unsafe state. Now resource allocation graph algorithm. Suppose that process Pi requests a resource Rj. Request can be granted only if converting the request edge to an assignment edge does not result in the formation of a cycle in the resource allocation graph. Next, we'll see Banker's algorithm. This is used when there are multiple instances. Each process must have a priority claim maximum use. When a process requests a resource, it may have to wait. When a process gets all its resources, it must return them in a finite amount of time. Then data structures for the Banker's algorithm. Here n is the number of processes and m is the number of resource types. So you have different matrices like available, max, allocation, need. Available in available vector of length m, if available of j is equal to k, there are k instances of resource type rj available. Max is an n into m matrix. If max of I comma j is equal to k, then process pi may request at most k instances of resource type rj. An allocation is a n into m matrix. If allocation of I comma j is equal to k, then pi is currently allocated k instances of rj. Need is also an n into m matrix. If need of I comma j is equal to k, then pi may need k more instances of rj to complete its task. Need of ij is equal to max of ij minus allocation of ij. Next one is safety algorithm. We have to follow four steps. First one is let work and finish be vectors of length m and n respectively. Initialize work is equal to available. Finish of I is equal to false. For I is equal to 0, 1, etc. up to n minus 1. Second step is find an I such that both finish of I is equal to false, need of I less than or equal to work. If no such I exists, go to step 4. In step 3 is work is equal to work plus allocation, finish of I is equal to true, go to step 2. In step 4 is if finish of I is equal to true for all I, then the system is in safe state. So this is the safety algorithm. Then resource request algorithm for process PI. Request I is equal to request vector for process PI. If request of j is equal to k, then process PI wants k instances of resource type rj. You have to follow three steps. First step is you need to check if request is less than or equal to need. If it is true, go to step 2, request less than or equal to available. If it is true, go to step 3. Step 3 is available, you need to decrement by available minus request. Allocation will be allocation plus request, and need will be need minus request. If it is safe, that implies that resources are allocated. If it is not safe, process must wait and the resource allocation is restored. That's all for today. Thank you.